be talking about the movement of plate tectonics. Our observations are: 1. There are 12 tectonic plates and most volcanoes occur on the edge of these plates. An example is the Ring of Fire in the basin of the Pacific Ocean. Second observation is the tectonic plates move at a small rate of 1 to 15 centimeters per year, which has been going on for millions of years. Our third observation is plates move each year because of compressive stress, which squeezes rocks together between Earth's layers. Powerful earthquakes tend to strike areas where this compressive stress is present.
Our hypothesis is that plate tectonics cause volcanic eruptions and earthquakes. These natural phenomena can be explained by the following pictures and formulas. The first picture shows a top view of the two plates with two opposing forces on each side. The opposing forces is what causes the plate to diverge. The second picture shows bearing stress. Bearing stress is equal to compressive forces over area perpendicular to the compressive load. The third photo shows shear stress. Shear stress is equal to viscosity multiplied by the velocity gradient.
To be able to describe this flow of geophysical fluids, we need to obey important concepts like Newton's second law and the conservation of energy. To start, a fluid is assumed to be incompressible. This essentially means that the density of the fluid that is the driving force of the tectonic motion, or convection, will have no appreciable change with an increase in pressure. Because of this incompressibility, the forces that are being applied to the fluid will almost be directly applied to the stress on the plates. We must also take into consideration that the fluid is assumed to be a Newtonian fluid. This means that there is a linear relationship between the shear stress and the strain. An increase in shear stress would result in a greater movement of the plates.
The gradient of temperature in the mantle creates convection cycles. The convection cycles bring hot material from the mantle up towards the surface. As the mantle reaches the bottom of the lithosphere, it diverges. The movement causes stresses on the lithosphere, which causes it to split. This is called a divergent boundary. These divergent boundaries typically happen in the middle of the ocean and underneath oceanic lithosphere. Based on our research, our conclusions are that layers of the lithosphere thrust deep into the mantle, which increase in heat and cause the plates to shift due to convection. We also discovered that volcanic and earthquake activity are directly correlated to the movement of plate tectonics. Although there is little movement, the slightest shift can cause the greatest devastation.
I fell into a burning ring of fire. I went down, down,